I'm Anil Kumar. Welcome to my series on properties of quadratic functions. We'll actually take up 8 questions of this worksheet. Let me begin with the very first one, which is how do we sketch a transformed quadratic function? Using transformations, graph the following 3 functions starting from the graph of y equals to x squared. So we'll sketch the graph of y equals to x squared, and then we will sketch the transformed function on this. Y is equals to x squared means that we'll go with the steps of 1, 3, 5, 7, right? So 1, and then it is 3, which is 4, like this, right? So here we'll keep it just this much, right? So we have a parabola which is this, and this graph is of x squared. Now when we have to show the transformations, this is the vertex form, and clearly in the vertex form what happens is that you have to translate x minus 1. That means the vertex now is at 1 minus 4. And how did it appear there? It was translated 1 unit right and 4 down. That is the transformation, right? So 1 right and 1, 2, 3, 4 down. So that is how each point is going to get translated, right? So the key points which we considered, that is to say, let me write down here the key points which we have used, steps. So steps used were 1, 3, 5, 7, and so on, right? And this is for y equals to x squared, right? So that is how we got this curve, right? So each unit is 1 unit for us, right? Okay. So now we can say, well, every point is translated 1 unit right, 4 down, right? So let me write down here the translation, which is 1 right and 4 down. Correct. So if I do that, I get a graph which is right there, right? So this is 1 step, and then we'll go 3 steps, 1, 2, 3. From the symmetry, that is the point. So we get a parabola which is kind of like this. Is that clear to you? So that is how we are going to sketch the transformed function y equals to x minus 1 whole squared minus 4. Now let's take the next one. Now let us see what is the transformation. Here we have a reflection, right? We have a reflection, and then it is stretched by a factor of 2. So the translation here is reflect on x-axis, stretch by 2, and then 6 down, in short. Is that okay? So that is how we are going to do it. That is the transformation. So let me again sketch this. Since we are actually reflecting it down and then going upwards, and 6 down, okay, so what I was thinking is we have to put a scale slightly above, right? So let me just this time make us something like this. Okay. We could actually also change the scale, right? So we can use the y values as 2. That could make sense. So in this case, what we will do here is we'll use this as 0, and here we'll use this as 2. So that will take care of the stretching factor and also moving 6 units down, right? So we'll have more room here, right? So we'll have minus 2. So I've changed my scale. As you can see, each vertical step now is of 2 units, right? So in that case, let me just sketch the parabola first. So this is 0, 0 is 1 point, and then we have 1, 1, right? So at 2, we have 4, which will be here, and 3 is 9, right? So it is 2, 4, 6, 8, and somewhere up there. So we do have a parabola which could be going through this. So let me just sketch this part here. Okay, so this will go here. So okay, so that becomes the x square graph. Since the scale is changed, it looks slightly different from what it was looking earlier, right? Okay, minus 2. Minus 2 means we'll do these two steps together. So every point will be multiplied by 2, and that 1 becomes 2 and with a negative sign. So this actually comes on this side right there, correct? So that is minus 2. And 4 times minus 2 is minus 8. So we have this as 2, 4, 6, 8, right? So that is our next point. So we'll consider these 2 points and sketch the second graph, which is a transformation where we have considered minus 2x squared. So this is what we have as y equals to minus 2x squared. Clear? Now, 6 is minus 6 is we have to translate everything 6 units down, right? So 6 units down will be, this point will be shifted 2, 4, and 6, right? So that is 6 units down. And then this will be here, right? So that will be 6 units down. So our graph will now look like this. So that becomes the graph for the given function using transformations. Is that clear to you, right? Now the next one here, we have a vertical compression by a factor of half and also a reflection. So we have a reflection plus we have a compression by half, right? So that is this part. And then as far as translations are concerned, we have 2 units to left, right? 2 left and 1 down. Is that clear to you? So that is the transformation which we are going to do on our graph, right? So we can have this normal scale. So we are again opening up and then coming downwards. So let's use something. We'll have more space down. Okay. We'll use the normal scale, which is 1, 1. So that is 1, and then 1, 2, 3, 4. So that becomes the value, correct? So we have a graph which is kind of like this. So all these curves should be very smooth at the turning point. So that gives you y equals to x squared. And now what we are going to do here is that we'll do it in 2 steps. First, we'll incorporate this particular part, which is the reflection and half of it, right? So every point here will be half of it. So instead of going 4, here we'll go 2 down, correct? So here this was half. So the half of 4 is 2. So every point you just multiply by, what do you say? So this is 1, 2, 3, 4, correct. So 4 times minus half is minus 2, right? So we get minus 2 here for this value. And when it was 3, it is 9. Square is 9. Half of 9 is 4.5, right? So 1, 2, 3, 4.5. That becomes the next point. So we have a graph which is kind of like this, right? This is the graph which I have drawn is y equals to minus half x squared. So every point has been reflected and vertically compressed by a factor of half. So you just multiply by half, correct? The final graph here is to translate 2 units left and 1 down. So this particular point, 2 units left and 1 down will come here. So this vertex moves like this, correct? Accordingly, all these points will move 2 units left and 1 down. So this is half down from here, so that I could go from here half down. And then we have the next point, which is 1, 2 units left and 1 down, right? So 2 units left and 1 down. So that is what we have to do with each and every point. So this point here moves 2 units left and 1 down. 2 units left and 1 down. Here, 2 units left and 1 down. Do you see that? So from the symmetry, we get this point here, And this point here, 2 units left and 1 down will mean this, and then symmetrically we could place it here. So we do have a curve which is kind of like this. Is that clear to you? So that becomes the graph of the third function. So I hope from here it is absolutely clear how do we sketch a quadratic function using transformations, right? So there are many ways to do it, but if you have to show the transformations, it is good to show stretches and compressions and reflections, that is multiplication factors, in one shot and translations in the other shot, right? So in two graphs, you can easily show the transformations. The first one had only translations, so we have only one graph to represent the transformed function. So I hope that is absolutely clear. So you have seen how to sketch a quadratic function using transformations. Now let's continue with the knowledge-based questions. Question number 2 is, state the equation of a parabola in any form that has a vertex minus 4, 5 and is thinner than y equals to x squared. So we could write an equation which is, let's say we can write this as y equals to, now when we say thinner, it means what? It means vertically stretched, right? So we could write, say, for example, 3 times, right? X, vertex is minus 4, 5, so x plus 4 whole square plus 5. So that would be thinner, right? So this value of 3 makes it vertically stretched. So basically we need vertically stretched graph. Is that clear? So that means a value is greater than 1. Now question number 3 is, state the equation of a parabola in any form that has zeros 1 and 8 and is congruent to minus 2x squared. So congruent to this means the value of a should be minus 2. Then they are congruent. We are given the zeros, so the best form is the intercept form, right? So a is minus 2 and the intercepts at 1 and 8. So we have x minus 1 times x minus 8. Question number 4. State the equation of a parabola in any form that has vertex at this point and which passes through that point. So we may have to do some work here. Y equals to a times x plus 3 whole square plus 2. Now substitute this point to find the value of a. So we have 14 equals to a times minus 1 plus 3 whole square plus 2, correct? So let's continue. So in this, there's a small space. Let's bring this 2 on this side. So we have 14 minus 2 equals to a times minus 1 plus 3 is 2. 2 square is 4. 4a, right? 14 minus 2 is 12 equals to 4a. And that gives you the value of a as 3, right? So we get a equals to 12 over 4. So that means a equals to 3. Once we have this value of a, we can write down the equation, and the equation will be y equals to, a is 3 for us, and we have x plus 3 whole square plus 2. Clear? Question number 5 here is, find two symmetric points of the curve y equals to minus 2x square plus 2x minus 6. Now symmetric points are the points which are same distance away from the axis. So the best symmetric points are, you find the y-intercept, right, and its image. So that you get in partial factored form, right? So when you write it in partial factor form, you get that, correct? So that is what is required. So I hope you understand the concept. So we can write this equation as y equals to, let's do partial factoring. So we can take minus 2x common, right? So from the first two terms, and we get x minus 8 divided by minus 2 is 4, right? And we have this as minus 9. So we have clearly 2 points here. And what are the 2 points here? If x is 0, then y value is minus 9. So one point is 0 minus 9, and that is your y-intercept, right? This is your y-intercept. Clear? The other point is when I substitute 4 here, I get minus 9. So that is the other point for this particular function. Is that clear to you? Perfect. So basically, this will be a parabola which will open kind of downwards like this, since this value is negative. And you will notice that these 2 points are at minus 9. Correct? So let me just, the y-intercept, this is your axis. So this point here will be 0 minus 9, right? And this is at 0. And this point here will be 4 minus 9. Oh, sorry, 4 minus 9. Do you see that? So at 4, that will be minus 9. So that is how you are going to get your parabola, correct? So I hope this concept is absolutely clear. So these were 4 questions straight on writing the equation from the given information. Now let us take some application questions based on the properties of quadratic function. Question number 6. Maple Leaf Sports and Entertainment is thinking of changing their ticket price for the next season. They have developed a formula that describes how their overall profit per game, P, will change for the number of 50 cents increase to their ticket prices. The formula is P equals to, let me rewrite the formula here, P equals to minus 50 x squared plus 9500 x plus 100,000. By how much should they increase their ticket price to maximize profit, right? So that is the question for you. Now, what does X represent here? So they have developed a formula that describes how their overall profit per game will change for the number of 50 cents increase, right? So highlight for the number of 50 cents increase. So that's kind of important, right? So X here is number of, X is number of 50 cents increase. Do you see that? So X is number of 50 cents increase. So what is going to be the increase? So increase will be 0.50 times X. This is very important to understand, as that is where you might just do a mistake, right? But keeping this in mind, I like you to follow one of the methods which is familiar to you and find the maximize for X, right? That is what it is. So a popular method here is definitely to do completing the squares, right? So that is the popular method to go about, correct? So what we can do here is we can definitely do completing the squares and then answer this question, correct? Okay, so we'll do that. There are other very good methods. For example, partial factoring is a better method, but we'll do completing the squares since that is more popular, right? So to complete the squares, I have to factor the leading coefficient, and I get what? X squared. Divide 195 by 50. First, the sign changes. So when you divide, this goes this, and it goes 1 times, and then 9, 190, right? So we get 190, and this is plus 100,000. Now the second step is we'll do half of 190 and add and subtract its square. So we have, that is the completing the squares step, right? So that is 95. So 95 squared minus 95 squared plus 100,000. We are only interested in completing this part to figure out what should be the increase in price, right? By how much should they increase their price? We only want increase in price, right? To maximize profit. So increase in their price. This is what we want, right? So here we get, to complete the square, we get X minus from here 95 whole square minus all this, which is, we can use the calculator to get this value. 95 squared equals to 9025. plus 100,000. You already have your answer here. That is the vertex form answer. 95 will actually maximize. Let's open the bracket, complete the job, which is x minus 95 whole square. This minus and minus becomes positive, and will now multiply 9025 by 50. So we get 451250, right? So 1 0 more, 4 9s 45, correct? 1 2 3 4, 1 2 3 4 5 6. Okay, so 100 divided by 2, that's correct. So that is what you get when you multiply by 50, and here we have 100,000. Sometimes they might even ask what is their net profit, right? But in this question they are not really interested in this part. But here we have our final equation in the form of this, right? So now we'll add to this 100,000. So what we get here is 551250. Correct. Now we can write down the answer. So clearly it is 95 which will maximize. So to maximize, we have x equals to 95 for maximum profit. However, what is the increase? So the increase here is how much? Increase is equal to 0.50 times 95. So it is not $95. It is half of $95, which is the increase, right? So that is kind of important to understand, right? So we have to do half of $95, which is 47.5 cents, right? So which is approximately, you can say, 47, right? 47.5 cents. Right. So it could be rounded to, that is in dollars, I'm so sorry. In dollars, right? So this is in dollars, not in cents, right? Okay. So it could be, we could round this, so $47.50 increase. Right, so that is what is recommended, right? So you could round this to $48 or $47, but that gives you the maximum profit from the given condition, right? So I hope that makes sense. We are almost at the end of this worksheet. 2 more questions to go. Both are application questions. Question number 7. A quadratic is congruent to y equals to minus 2x squared plus 11x plus 4 has the same y-intercept as y equals to 3x squared plus x plus 10 and passes through the point 5, 2. Find the value of b in its standard form represented by y equals to ax squared plus bx plus c. You can always pause the video and answer this question. Now to solve this, let's understand the situation. It says quadratic is congruent to this particular function, right? It really means that the value of a has to match. So in our equation of y equals to ax squared plus bx plus c, a will be equal to minus 2. It could be plus 2 also, right? So we have the first part, which is minus 2x squared. It could be plus 2x squared also, right? Now has the same y-intercept as the other one. So y-intercept means c, right? So in this quadratic form, we have the c value, which should match with 10. 10 is the y-intercept, right? So c is equal to 10. So we get the equation as y equals to minus 2x squared plus bx plus 10. Now we are given that it passes through the point 5, 2. So 5 is the x value and 2 is the y value. So we can write 2 here for y and 5 for x. So we get minus 2, 5 squared plus 5b plus 10. Now b is the only unknown. We can really find this answer. Bringing 10 to the left side, we get 2 minus 10 equals 2. 5 squared is 25 times 2 is 50, right? Plus 5b. So this is minus 8 and we'll add 50 to this. So write 50 minus 8 is equal to 5b. Now let's solve it on the right side of this page. So we have 42 equals to 5b, or 42, right? So, or 42 divided by 5 becomes the value of b. And therefore, the equation is y equals to a values minus 2x squared. B we just found as 42 by 5. We'll write this as 42 by 5. This is the b value, x plus 10, right? So we need to find the value of b. So the answer is b is 42 divided by 5. Clear? So that is how we are going to answer this question, right? Now we could have done this with a equals to plus 2x squared also, right? So in that case, we could have another value of b. That is also possible. Perfect. So these are, this is definitely one of the solutions. The other one you could do is, you can try with a equals to 2, right? Even then we have a congruent function, and you will get a value of b, which will also be the correct answer, right? So this will be plus 50 in that case, right? So we'll have, in this case, minus 58 divided by 5. That will be the b value. Perfect. So I'm not doing that, just finding one, as it says find the value of b in its standard form. So if this would have been values, I would have definitely found the other value also. Okay. The last question here is, the parabola passes through minus 2, 8 and 1, minus 1 with the y-intercept of minus 4. Determine the vertex of the parabola. So we have the y-intercept. So that means if I write y-intercept, okay, something went wrong. So y-intercept. So y-intercept is minus 4. It means the equation should be what? The equation has to be y equals to ax squared plus bx minus 4, right? So if I substitute 0 here, we get y-intercept of minus 4. Standard equation, standard form gives you y-intercept. Now, this equation passes through the point minus 2, 8. So substitute 8 here. So when I substitute 8, we get 8 minus 2 for x. So we have 4a minus 2b minus 4, correct? So bringing 4 to this side, we get 8 plus 4 equals to 4a minus 2b, which is 12, right? 12 equals to 4a minus 2b. Dividing by 2, we get 6 equals to 2a minus b. Let's call this as our equation number 1. Now let's substitute the other point in the equation, which is y equals to ax squared plus bx minus 4. We'll now take the point 1 minus 1. Substituting, we get minus 1 equals to a plus b minus 4. That gives us minus 1 plus 4 is a plus b. So we have 3 equals to a plus b, and that becomes our equation number 2. Now from equation number 1 and 2, if we just add them, so if I add these two equations, then b and minus b cancels, and we get 3 plus 6 as 9 equals to 2a plus a as 3a. So we get 9 divided by 3 as the value of a, which means a is 3. Correct? So we have the value of a as 3. Substituting a3, we get 3 equals to 3 plus b, so b is 0, right? So b is 0 for us. Since we have all these values, we can now write the quadratic function. Correct? C already was c equals to minus 4. So we have our equation, which is let me write down right here. So our answer here is that the equation is 3x squared minus 4. Correct? So that becomes the equation. You can verify if I substitute 1 here, right? So we get 3 minus 4, which is minus 1. If I substitute minus 2 here, 2 square is 4. 4 times 3 is 12. 12 minus 4 is 8. It works. Correct? So that is how we are going to solve it. So with this, we come to an end of our solutions to the worksheet, where we have took these 8 questions, starting with the very first, where we learn how to sketch the graph of a quadratic function using transformation, right? So I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.